let's do that. So we'll have this. This equals the integral from 0 to a. This time I'll write a to the 4th power. And sine squared theta is 1/2 times 1 minus cosine 2 theta. And cosine squared theta is 1/2 times 1 plus cosine 2 theta. Oh, let's put on d theta. These 1/2 times 1/2, I can pull that out. Let's see, I'll have 0 to a to the 4th times 1/2 times 1/2 times 1 minus cosine 2 theta times 1 plus cosine 2 theta. Now I'm going to ask you a question that might seem a little silly. What is the variable in this problem? Theta. Theta is the variable. A is a constant. So I'm going to do what I usually do with constants. I'm going to pull a to the 4th to the front of the integral. And in fact, 1/2 times 1/2 is 1/4. So I'm going to pull out 1/4 a to the 4th. So the integral from 0 to a. And this part here, we're going to FOIL this. In fact, look, I got a minus and a plus, so that makes the FOILing kind of nice because it's going to be 1. The middle term's going to cancel out because I'll have negative cosine 2 theta plus positive cosine 2 theta when you multiply the inside and the outside. And then I'll have these two multiplied together minus cosine squared 2 theta, d theta. Now I need that identity again. 1 minus cosine squared 2 theta. In fact, let me do this. I'm going to write this as 2 separate integrals. So I'll have 1/4 a to the 4th. That whole times this whole thing. The integral from 0 to a, remember 0 to a, those are values for x. So 1 d theta minus the integral from 0 to a, cosine squared 2 theta, d theta. Well, I didn't need parentheses, but all right, I put them. All right, so I got that. Now, this will be 1/4 a to the 4th. And let's go ahead and say, what's the antiderivative of 1 d theta? That is theta. Now remember, these values, 0 to a, those are for x. I've got to go back to x. And then I'll have minus, I need an identity here. Look, I have the identity right here on the previous page. And my angle this time is 2 theta. Now what you want to see is this 2 theta, that's represented right here. What happens when I use the identity is this angle doubles. This will become 4 theta. So I'm going to have integral from 0 to a of 1/2 times 1 plus cosine 4 theta d theta and before I go back to x, I'm just going to finish up with everything I have here. 1/4 a to the 4th. Okay, we had theta that we still have to deal with here, and I'm looking at this. I'm going to factor the 1/2 out. So 1/2 integral from 0 to a of 1 plus cosine 4 theta d theta. Let's finish up with the integral parts at least here. I'll just recopy 1/4 a to the 4th theta from 0 to a. Those are values for x. Now 1/2, what's the antiderivative of 1? It is theta. What about the antiderivative of cosine? Sine. Now that 4 theta, that's really a u substitution, which, what's it going to do to this problem? Plus 1/4 sine 4 theta. And this is gone from 0 to a. Those are, again, values for x. Because it's a definite integral, I don't need to put on plus c. The reason I wanted to work this problem was because of the kind of going back to x right here. And so, although if I would have changed my limits of integration from the beginning, I wouldn't have to worry about that. So, I'm torn here between two things. Showing what I wanted to show or taking the easy way out. And I think I'm going to take the easy way out. Okay, go back to where we first did this substitution, right here. And these were values for x. Well, if x equals 0, this right here, can I find what theta is? 0 is a sine theta. 0 over a is sine theta. So 0 equals sine theta. What angle does sine theta equal 0? At 0. For our purposes here, at 0. 0 and pi is correct, but when we define these trig substitutions, look at the interval they gave you for, yeah, so pi doesn't count in our case here, just 0. Now what about, so 0 will stay 0 as a value for theta. What about, here, let me say when x equals a, then we have a equals a sine theta. Divide both sides by a. A over a is sine theta. So 1 equals sine theta. What angle? Theta is pi over 2. So all of this where I said, okay, those are values for x. Those are values for x. You know what? Now we're going to make them theta. So back over here, I'm going to put this in red. 0 equals theta, and pi over 2 equals theta. Let's change it here as well. 0 is theta, pi over 2 is theta. And now I don't have to go back to x, since this is a definite integral. If it was not definite, I'd have some stuff to show. Yes?
On the fourth line from the bottom one to the top, at the end you have 1/4 a to the 4th. On the next line you don't distribute to the later term. I'm sorry, the fourth line. Yes, that one.
Oh, this.
Yes, you don't distribute it to the other term.
Oh, I have my brackets. So I have it this here. So I will see these brackets right here. I think these brackets kind of saved me on that. I think. So we'll just make sure we have it distributed on the next step. Thank you. So let's go ahead and distribute this. It does go with, in fact, see, this will go with both. This will go with all three. So I'm going to have 1/4 a to the 4th times theta. That takes care of this one. Minus 1/8 a to the 4th times theta. Those are like terms. And then I have a minus here. That'll make this negative. In fact, this 1/2 will make that 1/8. And 1/4 times 1/8, that'll be minus 1/32 a to the 4th sine 4 theta. We're going from 0 now to pi over 2. So every theta will plug in pi over 2 and then get that answer and then plug in 0. So 1/4 a to the 4th times pi over 2 minus 1/8 times a to the 4th times pi over 2 minus 1/32 a to the 4th times sine of 4 times pi over 2 minus, I do want you to think about what happens when you plug in 0. What happens when I put 0 in here? 0. What happens when you put 0 right here? 0. What about the sign of 0? That is 0. So 0 is going to give me 0. It does not always give you 0, but it gives me 0 right here. So what about right here? This is the sine of 2 pi. That's going to be 0, the sine of 2 pi. So we're only left with this. I can clean it up a little bit, but pi over 8, a to the 4th, minus pi over 16, a to the 4th.